So, hello everyone. So, today we are going to start the new topic that is bits versus qubit. I hope you know some little bit idea about the bits. So, in classical computers, what do we call this bits? Means it is nothing but it is the smallest unit of classical information. It means if you want to represent any information or if you want to store any information. So in classical computer, we used to have some bits. So in the form of bits, it is going to store some information. That is what the classical information. So we always represent these bits with either 0 or 1. But if we are not going to represent with both 0 and 1. Only we can able to represent exactly either 0 or 1. So we cannot able to represent both at any time. So that is what the bit. So if you see this bit, so this bit is nothing but the binary digit. So who coined this? There is a scientist called John Cooke in 1948. So what is this bit means? It is the atomic unit of every digital system. If we consider every digital system, this bit is nothing but it is the atomic unit. It means smallest unit. And also, if you see any photo or any song or any videos or any apps and any other things, so these are nothing but it is a long strings of zeros and ones. It means we are going to store photo information, song information, video information, and app information. No? So all those things are going to store in a long strings of zeros and ones. It means long string of zeros and ones means it is going to have a huge amount of information. For that purpose, we are using long strings of zeros and ones. For smaller information, we are using shorter string of zeros and ones. So this is what the thing. And also, what is the physical reality of these things? So if it is nothing but a physical switch, it means we are having electrical switches, no? So like that. So if you on, it will work. If you off, it doesn't work. So it means that there are two things. So on and off means on represents the one and off represents the zero. So like that, it is going to act like a like that it is like that the physical species is acting like a bit, and also um, so that is the thing. And because bit is always only in the on definite state, means if we consider any bit, always it will be in only a single definite state. It won't be in multiple states simultaneously. That's why these classical computers are perfectly predictable. So here the classical computers are going to exist in a single definite state, no? So that's why we are predicting everything. And also, whatever the information that we are having in this classical computer, we can able to copy this information, we can store the information, and also we can transmit the information without any loss. So that's why this is the reliability which has built in the entire digital age. And also, if you see the bits and bytes, suppose if you are having any byte, one byte is equal to 8 bits. It means if you are forming 8 bits, so those 8 bits are equal to one byte. So 2 bytes means 16 bits. So like that. For every byte, it is going to store 8 bits. And also, if you see the gigabyte, if you consider a single gigabyte, it is going to hold 8 billion bits. So they are going to function deterministically. So this is the thing. And the next one is now we are going to see the qubit theorem. It means so previously we have discussed it about the bits. So bits is nothing but zeros and ones. It means we are going to represent the zeros and ones in a single definite state. Either it will be in zero state or either it will be one state. But it will not be going to exist in both the states simultaneously. That is what that bits. So for example, if we take the general example for the bits, so while we are flipping a coin, either we will get head or either we will get tail. But we won't get both head and tail at the same time. So that is what the classical example for the classical bit. And also if you see this qubit, so this qubit is nothing but it is going to exist in a superposition. Superposition means nothing but it is going to exist in multiple states at the same time. That means in the previous case, we have seen that classical computers are going to exist in single definite state, that is either 0 or 1. But in qubit, it is going to exist in both zeros and ones simultaneously. So that's why it is very faster than classical computer. So that is what the qubit. So qubit is also nothing. We are also calling this qubit as quantum bit. So qubit is also often called as quantum bit. So this is also the fundamental unit of quantum information. So for classical information, bits are the fundamental units. For that, for the quantum information, qubit is the fundamental unit. So who coined this term qubit means Benjamin Schmalzer in 1995 year. And also you can see this diagram here. This is the classical bit and this is the qubit. So when in classical bit, whenever you flip the card, you are going to get either head or tail. It means either we are going to get either 0 or 1. But we are not going to get both heads and tails at the same time. But in qubit, what we are going to get? So we are going to represent in both multiple states. It means we are going to represent in both 0 and 1 state simultaneously. So it means it is going to exist in multiple states at the same time. So whenever it is existing in multiple states at the same time, so that is what the superposition. And also, what is the example for this qubit means? So whenever you flip the coin, it is going to exist in both hands. It is going to get both heads and tails at the same time. That is 50-50 probability. So that's why it is called a qubit, which is going to exist in multiple states at the same time. So until you measure it, so it is going to be in superposition. After measurement, it is going to single definite state. That is what the thing. And also, if you see the physical reality, it was really a quantum system. It means if you consider the electron spin up or spin down state, or if you consider the proton's polarization state, so like that, you can able to see the physical reality. So that is what the thing. And there is also a black sphere. It means you are mapping a qubit state. It means if you want to map a qubit state, we require the black sphere. It means you see. So if you consider any bit, it is going to live on the line between the 2 points. It means there are 2 points. Between those 2 points, there is a line. So on that line, this bit is going to live. So and also it is going to live on the surface of a sphere also. It means if you consider the black sphere, so on this black sphere, it's going to the qubit is going to live on the surface. So you can see the surface here. So you can see this. So like that, a qubit is going to live on the surface of the sphere. It means nothing but it is an intercontinuous one of the state. Now you see two states versus a sphere. Suppose if we consider the classical grid, it is having two states, that is 0 state and 1 state. So if you consider a qubit state is a point on the surface of the unit block sphere. So what is qubit state means? If you consider the block sphere, it is just a point on the surface of it. And also it is parameterized by two angles, that is theta angle and pi angle. Theta is nothing but polar angle and pi is nothing but the azimuthal angle. So we will see all those things in block sphere. That is what the thing. And the thing is next one is poles and equator. Here we are going to have two poles. One is north pole and another one is south pole. So north pole represents the K0 and south pole represents the K1. So that is one. And also here we are having some equator now. So this equator represents the equal superposition. So equal superposition is nothing but we are having two qubits now. So both the qubits are in perfectly balanced state. So that is one. And the next one is probabilities. So we are having Ket0 and Ket1 now. If you measure the probability of Ket0 and Ket1, so it means we are going to have the equal probabilities. And also here we are having a theta now. So you can see the theta. So this theta is nothing but it is the angle which is going to determine the likelihood of each outcome. So for every outcome, it is going to determine the likelihood. Next one is continuum of information. So if you see this geometry or if you see this diagram, it is showing why a qubit is going to carry a continuous information while remaining one bit upon measurement. So that's the thing. You can see. So if you are having n bits, it is going to hold n 2 power n patterns. In the same way, if you are having n qubits, it is also holding the 2 power n patterns at a time. But these 2 power n patterns are not at a time, but this in quantum in qubits, it is going to hold all 2 power n patterns at a once. So that is what that thing. So that's why young bits represent exactly two power n configurations at any given moment. So that is what the thing. If you see this in classical qubits, so only it is going to take single combination. First 0 0, next 0 1, next 1 0, it 1 1 1. It means it is going to hold only one state at the time. But if you see these qubits, it is going to hold all the states at a once until you measure it. So that is what the specialty of the qubits. And if you take n qubits, you are going to have two simultaneous states. But if you take n qubits, out of two power n state, it is going to consider only one state. So that is what the thing. You can see here. So if you consider the classical computer, it requires two power n numbers in order to display the n qubits. Suppose if you are having 30 qubits, it requires 1 GB. 40 qubits, 1 TB. 50 qubits, 1 TB. And if you consider the 300 qubits, it requires more than an atoms in the observable universe. Means, so what are the how many atoms are there in this observable universe? So if you consider 300 qubits, it requires more than those atoms. So that is what it is saying. So you see, so if you are having a book, you are reading any book, whenever you are reading any book, it means it is confirming that there is a certainty. It means you are going to get in a certain probability outcome. It means whenever we pick a time, when we measure it, we are going to get a single outcome, that is either head or tail. So like that, whenever we measure any qubit, it is collapses into the single probabilistic outcome. So that is what the thing. And also, whenever we read a book, so we get exactly the 0 or 1 with 100% certainty. And also, there is no surface overheat. And also, here the measurement is perfectly repeatable every time. It means whenever we measure the thing every time, we are going to get perfect without changing the state. And also, now you see the measuring the qubit. It means before measuring the qubit, it is in superposition state. But whenever you measure it, it is going to collapse into the single definite state, either 0 or 1. It means it is collapsing into the classical state. That is what that is. They are also having gates and all those things. So that is what that is. So now you see the comparison. So classical bit versus qubit. And as you see here, qubits are not going to replace the bits, but they are going to specialize that where superposition and entanglements are going to create decisive advantage. So if you see the comparison of classical bit and qubit, so classical bit is going to exist in the zero state or one state, but qubit is going to exist in both the states simultaneously. That is superposition. And also, in classical bit, if you are having two power n states, it is going to use only one of the state in one of the state. But in qubit, if you are having two power n states, it is going to use all two power n states simultaneously. And also, if you see the correlation in the classical bit, this is independent. It means there is no correlation. But in qubit, there is an entanglement. There is a link between each particle. And also, if you see the operations, so in classical gates are irreversible. It means they can't come back. But in qubit, with quantum gates, they are reversible. And if you want to copy any information in classical computers, you can able to easily copy this thing. But in qubit, there is a no cloning theorem concept in which we cannot able to copy. And also, if you want to read any classical bit, it is a certain because we are going to have it single definite state. So you can able to easily predict that. But in qubit, it is based on the probabilistic collapse. And also, if you see the noise, so in classical bit, it is a robust one. It means it is approximately containing 10 power minus 17 errors. But in qubit, it is a fragile. It means it can easily destroyable. And also there is a decoherence in microseconds. And also if you look at the environment, classical bit requires a room temperature, but qubit requires the absolute zero temperature or vacuum temperature. And where qubits shine means, so if you see the molecular and quantum system simulation, so we are going to have a large scale optimization cryptography. There is source algorithm, and also there is an unstructured search. So that is Provost algorithm. So that is what the thing. So this is what all about the bits versus qubit. I hope you understood. So if you like this if you like this video, please like the video, share and subscribe, and comment it CFB. So we will come up with a new video in the next time. So this is what the bits versus qubits. So in the next video, I am coming up with a new concept. So until then, see you later. We'll see you in the next video. So thank you.